All right, let's get right into it. Today, we're tearing apart CVE 2026-29014. As an AppSec researcher, I gotta tell you, this one is a fascinating case study. If you're a software developer or a security engineer, this is an incredibly important look at how a couple of seemingly harmless architectural assumptions can lead to a total system compromise. We're gonna deconstruct this from the ground up, look at exactly how the code failed, and figure out what we can learn from it. We're looking at a massive unauthenticated remote code execution, or RCE flaw, disclosed in April 2026. It carries a CVSS version 4.0 base score of 9.8 out of 10. It really doesn't get much more critical than that. Basically, it's what I like to call a perfect storm of security oversights. It literally lets attackers trick a web server into writing a malicious file and then executing it as legitimate code. And the kicker? It completely bypasses all passwords and administrative controls. Anyone out there with internet access can send a crafted sequence of messages to the site's WeChat module and just take over the whole shebang. So here's how we're going to break this down today. We'll start with the overview and design intent, move into the vulnerability abstraction, and then dissect the exact attack flow and root cause. After that, we'll cover the impact, the fixes, and wrap up with the bounties and key lessons. Okay, starting off with the overview and design intent, specifically the WeChat API integration. So what was this vulnerable component actually built to do? Well, it was designed to support the WeChat Open Platform, which is a really critical high-volume API ecosystem, especially for enterprise operations in Asian markets. The devs implemented a specific method to let site admins log into the CMS backend straight from their WeChat mobile app. Makes sense, right? It allows for rapid, event-driven automation. But to handle all those high-volume API requests, they used a local caching system. They were temporarily storing session data right there on the server's file system. And, this is exactly where things started to go off the rails. The flaw was really born from a couple of dangerous developer assumptions. First, they just assumed that any data coming from the WeChat platform was inherently trustworthy. And second, they figured their internal cache directory would be totally shielded from any outside tampering. They prioritized rapid API state management over rigorous data sanitization. All right, moving on to the vulnerability abstraction, let's talk about CVE-94, or code injection. At its core, this is a classic PHP code injection flaw. This happens when the strict boundary between what's data and what's executable code completely blurs. In a PHP environment, if an application takes raw, untrusted user input and dumps it inside a file that later gets included in the execution path, well, that data suddenly becomes active program instructions. It is a textbook example of unsafe persistence. Now, let's get into the really fun part, the attack flow and root cause. Let's dissect how this exploit actually works. The actual exploitation is a really elegant, multi-stage process that requires zero authentication. Step 1 is state manipulation. The attacker fires off a post request packed with a path traversal sequence. This primes the internal state, basically tricking a variable called login_code into holding the string array. Step 2, payload injection. Since the state is primed, a second request can sneak malicious PHP code straight into the from username field. The app unknowingly saves this right into a new file called array.php. Finally, step 3, the execution. The attacker just triggers that freshly cached file. It's a brilliant chain of input processing failures that hands over arbitrary OS command execution. So why exactly does the code fail? It all comes down to PHP string interpolation. Look at the logic here. The app builds the PHP cache file by wrapping the user input in double quotes. Now, in PHP, double-quoted strings evaluate what we call complex curly syntax. Because the developers use this method instead of storing the payload as pure harmless text, the PHP engine literally evaluates and executes the attacker's payload the second that cache file is loaded. Unbelievable, right? Let's pivot to the impact and affected scope. We're talking about a complete server compromise. The blast radius here is absolute. The attacker gets the exact same privileges as the web server itself. They can completely bypass all CMS administrative controls. They can rip into configuration files to steal database credentials, dump all your hashed passwords and customer data, you name it. They can even drop persistent web shells to maintain their backdoor access even after you patch the original bug. It's a total compromise that perfectly sets them up for lateral movement across your network. And listen, this isn't just some theoretical lab exercise. As researchers at Vulncheck and Security Week reported, exploitation absolutely surged right after disclosure. Threat actors were aggressively probing deployments with automated botnets, setting up callbacks, and dropping payloads. Active weaponization is happening in the wild as we speak. To put some numbers on it, public scanners see about 2,000 affected instances sitting out there on the open internet, mostly in Asia. But honestly, we have to be realistic here. The true scale is highly uncertain. Tons of these enterprise deployments are buried deep inside internal corporate networks or sitting behind web application firewalls. The actual number of vulnerable servers could be way, way higher than what public scanners can see. As for the software scope, MetInfo CMS versions 7.9.0 through 8.1.0 are vulnerable across all platforms. But there is one very specific platform-level limitation you should know about. On non-Windows servers, like your Linux or Unix boxes, this is strictly exploitable only if the /cache/WeChat directory already exists. Usually, that directory is only there if the WeChat plugin has been actively configured. Okay, let's talk about how to stop this. Fixes and mitigations, patching the logic. In version 8.2.0, the vendor completely ripped out the vulnerable logic. They ditched that dangerous double-quoted string interpolation. Instead, the fixed code relies on functions like JSON encode or var export. This is a real game changer because it finally reinstates that strict boundary between data and code. It guarantees that all inputs are serialized into safe, non-executive text formats before they ever touch the disk. Now, if for some reason you can't patch right this second, you need to apply these mitigations to block those automated botnets. Configure your web servers to return at 403 forbidden for unauthorized access to the entrance PHP script. If you aren't using the WeChat module, just delete that /cache/Weixin directory entirely. Get your WAF rules up, targeting that specific directory traversal string, and definitely disable dangerous PHP functions like eval and system in your server's PHP and on. Finally, let's wrap things up with bounties and key lessons. What can we actually learn from this flaw? So this 0-day was discovered and responsibly disclosed by Egidio Romano of Karma and Security. We don't have the exact bounty amount for this one, but let's be real, unauthenticated RCEs in enterprise platforms command massive payouts right now. I mean, look at Microsoft's recent 0-day quest. They awarded $2.3 million for similar high-impact bugs. This discovery just reinforces how incredibly valuable independent bug bounty programs are for catching these deep logic flaws in third-party API integrations. Which brings us to our absolute biggest takeaways. If you are a developer, your number one priority has to enforce secure coding standards to prevent code injection vulnerabilities before they are ever written. You have to treat any input that touches a file path as completely hostile, and you absolutely must replace unsafe string interpolation with strict data serialization, like JSON encode. And for the security teams out there, shift left. You need to be implementing automated scanning tools directly into your CI/CD pipelines. You want scanners specifically designed to catch these exact types of cache manipulation flaws and unsafe persistence methods during development, well before they hit production. Pair that with file integrity monitoring on your live web servers, and you've got a solid defense-in-depth strategy. So I'm going to leave you with this question to chew on. As these automated botnets get faster and faster at weaponizing new exploits, is your CI/CD pipeline truly equipped to catch the next perfect storm of unsafe persistence before it ships? Take a hard look at your tools, tighten up those coding standards, and stay safe out there. Thanks for joining me on this explainer.